If you've ever dealt with microservices, you know that things can get, well, messy, really messy. Today, we're going to demystify a really powerful tool for cleaning up that mess, the service mesh. We're going to break down what it is, why you might need one, and what the big players are.
It's a fun question, right? But it gets at a really serious problem. When you have dozens, maybe hundreds of services, how do you know what they're saying to each other? How do you keep those conversations secure? How do you even see what's going on? That is the exact problem service meshes were built to solve.
And this, right here, this is the core of the issue. See, in a big old monolith, when one part of the code talks to another, it's a simple, reliable function call. But when you explode that into microservices all over a network, every single one of those calls becomes a fragile, unpredictable network request that can fail at any moment.
So, how did we first try to deal with this new, complicated world? Well, the first attempt was to basically stuff all the networking smarts right into the application code itself. And you can probably guess, that created a whole new set of problems.
Yeah, the first wave of solutions were these big, chunky libraries. You might have heard of them, things like Netflix's Hystrix. The idea was to embed all that networking intelligence, retries, timeouts, circuit breaking, right inside the application. And hey, it kind of worked, but it came at a huge cost.
This approach just created a total nightmare downstream. Imagine you've got teams using Java, Go, and Python. You had to write and then maintain all this super complex networking code for each language. It led to this constant drift in configurations, a library version hell, and worst of all, it tangled up your actual business logic with infrastructure stuff. It just wasn't going to scale.
So out of this mess came a much more elegant idea. Instead of putting all that networking logic inside the application, what if we pulled it out and ran it alongside the application? And that, right there, is the big idea behind the service mesh.
And that word, decoupling, that's the magic word. A service mesh gives you this dedicated infrastructure layer that handles all that messy networking. This is amazing because it lets you developers get back to what they do best, building features. Meanwhile, the ops team can manage all the reliability, security, and observability from one central place.
Now, a service mesh basically has two main parts. The first is what we call the data plane. You can just think of this as the muscle. It's a whole bunch of really smart, lightweight proxies that sit right next to each of your services. This is that famous Sidecar pattern. They grab all the network traffic going in and out, and that's where the real magic happens.
So, if the data plane is the muscle, then the control plane is the brain. This is the command center. It's what configures all those little proxies out in the field. It sends out routing rules, security policies, you name it. But what's really important is that the control plane never touches a single packet of your application's data. That keeps it fast and out of the way.
Okay, so you've got this brain and all this muscle working together. What does that actually get you? Well, it turns out you unlock a bunch of operational superpowers that are pretty much impossible to get any other way. Superpower number one, instant observability. And I mean instant. Because every single request goes through a proxy, the mesh automatically gives you the golden signals for every service, your request rates, your error rates, your latency. You get cool service dependency maps, you get distributed tracing, and the best part, your developers don't have to write a single line of code to get it. That is a huge win on day one.
Next up, and this one is massive, zero trust security right out of the box. The mesh can automatically enforce mutual TLS, which just means all the traffic chit-chatting between your services is encrypted, period. It gives every service its own strong, verifiable ID and lets you make super specific rules, like say, the billing service can talk to the database, but the marketing service, no way.
And this is where the automation is a real lifesaver. A huge piece of this security puzzle is constantly rotating all those cryptographic certificates. A service mesh just does it for you, automatically. Trying to do that by hand across thousands of services is, like the quote says, pretty much impossible. The mesh just takes care of it. And the third superpower, getting really smart with your traffic. Because the mesh actually understands stuff like HTTP, it can make really intelligent routing decisions. You can split traffic with surgical precision for a canary release, you can route requests based on a specific header, or you can automatically trip a circuit breaker to stop one failing service from taking down the whole system.
This chart is a perfect example of that. Let's say you want to send just 1%, a tiny sliver of your live production traffic to a brand new version of your code, just to see how it does.
With a service mesh, that's just a few lines of config. You get to test in production, safely and with total confidence.
Okay, so let's say you're on board. You're thinking, I need this. The big question then becomes, which one do you pick? Well, the market is really dominated by two main players, and they represent two totally different ways of thinking.
On one hand, you've got Istio. You can think of it as the enterprise powerhouse. It's all about maximum flexibility. It's got a feature for absolutely everything. And on the other hand, you have Linkerd. It's built in Rust, and its whole philosophy is about radical simplicity, speed, and just being easy to use.
And you know, the biggest difference between them really boils down to the data plane proxy they use. Istio uses the incredibly powerful, industry-standard envoy proxy, which is written in C++. Linkerd, though, built its own super lightweight micro-proxy from scratch in Rust. And that one decision has massive, massive consequences for performance and how many resources they use.
Because of course, nothing is free. When you add a proxy to every single network call, you're going to introduce some overhead. We call this the performance tax, and it's a huge factor when you're choosing a mesh. The difference between the big players here is pretty shocking.
Just look at the median latency here. These are benchmark numbers. Linkerd adds about 6 milliseconds of overhead for a request. Istio adds around 17. Now, both of those are incredibly fast, don't get me wrong. But at the median, Linkerd's overhead is almost 3 times lower. But honestly, the number that really keeps architects up at night is tail latency. That's the P99. Think of it as the performance for your unluckiest 1% of requests. Under heavy load, Istio's tail latency can spike like crazy, and just one slow response can trigger timeouts all over your system. Linkerd, on the other hand, stays much, much more stable. That stability is absolutely critical when you're running at scale. And then there's the resource tax, which, let's be honest, is really your money. An Istio sidecar can eat up nearly 9 times more RAM for every single app instance than a Linkerd sidecar. Now, multiply that by hundreds or maybe thousands of pods, and you are looking at a massive difference in your cloud bill, just to run the mesh itself.
So, with all of that in mind, when do you actually need one of these things? It's a super powerful tool for sure, but it's not for every situation. It adds its own complexity, so you've got to be sure the benefits are worth the cost.
I love this quote because it just nails the entire idea. You need a mesh when the complexity of your network, your observability, your security, your reliability is starting to just crush your application developers. The mesh takes all that complexity and pushes it down into the platform, where it belongs.
And I'll leave you with one final thought to chew on. This whole space is still evolving really fast. This sidecar model we've been talking about is great, but the industry is already looking at what's next, new ways to reduce that performance tax even further. The evolution of the service mesh is not stopping. So the real question is your architecture ready for what's coming next?